Welcome to the AI for You Cafe today, and our speaker is Roberto Iacoviello from RAI Research and Development in Torino, in Italy. Hello. With his talk on video compression turns to artificial intelligence. My name is Carmen McWilliams, and I'm the moderator and organizer. I'm the director of the company Grassroots Arts in Cologne, Germany, and partner in the European AI for You, as well as of AI for Media project. And Roberto is like me, we are partners in this AI for Media project. So please take notice that this session will be recorded. No confidential information shall be shared in this cafe session. In this cafe, the speakers express their personal view and opinions. This is not necessarily the official AI for You project or AI for Media project opinion. So again, welcome everybody. Great you are here and participating in this cafe. What is the cafe about? It's an online forum to gain insight into the European AI scene. It's nearly every Wednesday. Participants get the chance to share knowledge and experiences and meet stakeholders from the various areas of AI research and application. So as you know, my participants can be interactive. You can be interactive by writing in questions to the speaker. In the panel on the right side, there's a text box. You can write in your questions, and I will read them afterwards to the speaker after the presentation. And we are looking forward for your questions. So please feel free to write them down. And now, coming to the main point of this cafe, I will introduce Roberto. Roberto Iacoviello is a lead research engineer, graduated from the Politecnico di Torino. Since 2007, he has been working at the RAI R&D. This is who doesn't know that, it's the Italian TV station, the main big TV station, where he has developed the following skills: end-to-end video compression for broadcast, computer vision algorithms, augmented and virtual reality, multimodal interfaces for TV, smartphones, and head-mounted display. His current research focuses on artificial intelligence, applied video compression and point clouds, next-generation TV services, in particular augmented reality and broadcast television. He follows the activities of the European Broadcasting Union, EBU, Digital Video Broadcasting, DVB, and actively participates in MPAI and MPAI, moving picture audio and data coding by artificial intelligence meetings. He has established collaborations with national and international research institutions in research projects and student tutorships, and he counts several publications in international journals and conferences. He has been working on several EC-funded projects, among which 5G City and, at present, 5G Tours and AI for Media. Yes, very impressive. Thank you, you are here, Roberto. Thank you again. Hello. How is Torino? How are you?
Hello, Carmen. Thank you for the nice presentation. And Torino, the weather is very good. The sun is shining, so it's a very nice, nice day. And I hope today we can have also a nice presentation. So let me.
I made you the moderator. Now you can try. Yes, I see already your presentation. So it's your floor, and I'm looking forward to hear video compression turns to artificial intelligence. So now it's up to you.
Okay, thank you very much, Carmen. So in this time slot, we speak about AI applied to video compression. And just a brief presentation of the RAI R&D video group. We manage the end-to-end compression chain from the camera to the grading software to hardware encoding, and this we support our production centers. We perform, colorimetric measurement and also subjective evaluation. Few years ago, we were one of the few labs selected from MPAI for the subjective evaluation of the VVC, the new standard, the versatile video coding. Then we have guys working on point cloud acquisition, 3D modeling, and augmenting and virtual reality. And our research focuses on deep learning applied to video compression and deep learning applied to point cloud. Just a moment. In particular, the noising of the point cloud. And, so today we are speaking about video coding. So why video coding? In the recent years, there has been a very big revolution in the world of film and television, and thanks to the advent of new digital formats. And I'm speaking about ultra high definition, that is 4K, 8K. For example, we are broadcasting 4K on satellite and also on internet. But the magic comes with the colors, and in the ITU 2020, ITU is the International Telecommunication Union, and the ITU 2020 is a recommendation. It comes with what we call wide color gamut, that is about more colors and more lifelike color saturation. That means now you can see on the TV set saturated red, saturated yellow, that is never seen before on the TV. And ITU 2020 addresses also the bit depth. That means the possible shades of colors. And now we have 10 bits. That means that we could have 1 billion colors compared to just 16 million of the previous standard. And the other new digital format, recent digital format, it's called high dynamic range, HDR. That is about pictures with a greater contrast between light and dark, but you can see better on the light side, because the new T-set are capable to reach 1000 candela for square meters compared to the previous technology that have just 100 candela per square meters. And you can see especially on the light sources, for example, that comes from sun, fires, and so on. High frame rate, HFR, it's about frame per second. Now it's up to 120 frames per second, and it's very effective in sports with very fast movement. That means that, video quality has grown exponentially, giving many challenges to the bandwidth transmission channel and also in media storage. And these make necessary to have a new video compression technologies that, of course, leave the quality unchanged. And moreover, the traditional video codec are facing a great challenge to deal with new media applications, such as point cloud compressions, 360 video, human genome compressions, and also neural network models compressions. And that means that there are strong requirements to find new algorithms for the future video coding standard, especially considering the rise of the AI technologies. It's an interesting time for people working in the video field, because there are 3 international groups working on AI applied to video coding. MPAI, that is a moving picture expert group, the Alliance for Open Media with their codec called AV1, and the MPAI is MPAI, the moving picture audio and data coding by artificial intelligence. And all of them are working on standards, and let me cite Andrew Tannenbaum, that is to say, the good thing about standards is that you have many to choose from. And it's kind of joke. I mean, the standard should be just one, but that's because I say that it's an interesting time. So it's difficult to forecast. Let me say, we sit on the Iron Throne, and here the reference is to that very successful TV series from HBO called The Game of Thrones. So speaking about MPEG in the last more than 40 years has developed many successful standards. For example, HEVC, the high efficiency video coding, the new standard VVC, versatile video coding, that are adopted by different product sectors and have a huge geographical coverage. And MPEG is no longer about audio and video. It deals with point clouds, compression, human genome, and industrial data. It has a wide range of interests. And speaking about AI, there are three groups working on AI applied to video compression. The first one is the neural network compression for multimedia that aims to define a compressed and interoperable representation of trained neural networks. And we are speaking about representation of weight and parameters. The idea is to reduce the model of the network, where model means weights and parameters. And also this group deals with the simplification of the neural network with dropping layers, dropping connection, and so on. And these allow the application to have a small memory footprints during the inference phase on devices that have a limited memory, limited computation capability, for example, IoT devices. And the other group is the video coding for machines that is focused in the case where videos are mainly consumed by machines. That means surveillance cameras, autonomous driving, and so on. Here, the example is, for example, in the airport where the surveillance camera are looking for weapons or guns and so on, and they send the video to the server that processes the information. I mean, there is no human in the middle. So the idea is to don't send the video, but extract locally the features, where locally I mean inside the camera, maybe running just the first few layers of a neural network. So extract the features, send the compressed feature to the server, and in the server runs just the rest of the layers of the neural network in order to save bandwidth, to save bits. And the last one is the neural network-based coding tools that's inside VVC. It targets the hybrid approach, that means AI combined with traditional video coding, and also deal with the encoding optimization of the encoder. And of course, we are speaking about the last standard that it is called VVC, versatile video codec. And in this work, they did a lot of work, especially in loop chain, but the conclusion was that because of the performance complexity trade-off, all this work is not part of the new standard. That means that in industrial application, complexity matters a lot. And the group is MPAI, the Moving Picture Audio and Data Coding by Artificial Intelligence. This is a newborn international organization, and is led by Leonardo Chiaglione. As you probably know, Leonardo was MPEG convener for more than 30 years. Then he noticed that MPEG is a very successful group, of course, but there are two drawbacks that, of course, now they are the two pillars of this new group. One is to exploit the advances on artificial intelligence to improve the video coding technology, and the other one is about the license. As you probably know, in HEVC now there are three patent pools and many companies that manage their own patents. So it's a kind of jungle. And that is because of the FRAND system. FRAND is the fair and reasonable declaration. So MPAI tries to replace this FRAND with a framework license. And what is this framework license? Is a structure of a license, structure in the sense that there aren't values inside the license. That means no numbers, no percentage, no dates, because the market will decide these numbers. It's just a structure that members should, should agree very early in the development of the standard. That means after the requirement phase, and in this way, at the end of the technical work, the license will be ready to the market. And there are many working groups in MPAI. The first one is the AI framework. It's a kind of orchestrator that manages the communication between the AI modules. For example, it manages the synchronization between these modules. Then we have the context-based audio enhancement, that it's about audio processing, and the idea is to keep relevant sound and to remove unwanted sound. For example, riding a bicycle, the idea is to remove the sound from wind or from the traffic, but of course to keep the sound from ambulance because it's important. The other group is a multimodal conversation that tries to improve the conversation between the human and the machine, leveraging on the emotion detection. That means, for example, that the machine should produce a speech or an animated face with a level of emotions consistent with the humans in front of the camera. And the server-based predictive multiplayer gaming, these address the problem where when the server doesn't reach the client, so the client should take its own decision in order to don't freeze the game or to don't stop even the game. The compression and understanding of industrial data, that it's about the risk of default of the companies. Then there is a compression of the human genome, and the HEVC, that is the AI enhanced video coding, where it's focused on the hybrid approach. The idea is to inject AI tools in the traditional video coding schema to improve the coding efficiency. The last group is the Alliance for Open Media. And as you can see, there are a very big company inside, Cisco, Facebook, Google, IBM, and so on. And because of this company, they are more focused on video on demand and internet streaming. I mean, more on broadband and less on broadcast. And they are using AI tools to improve encoder performance, the speed, and the video enhancement. And so what is video coding? I mean, to speak about video coding, it takes a lot, so I will give just a very big overview. And the problem is that at the TV studio, we have a huge amount of data. If we speak about HD, we have 3 gigabytes per second. That is, it's a very huge amount of data. Of course, we want to transmit a very small amount of data, but at the home user, we want to rebuild. I mean, we want to get back the huge amount of data. And this is what we call an ill-posed problem. That means it's not possible, of course, but there are tricks, or better said, there are algorithms that make it possible, and the set of these algorithms is called a video codec. And what there is inside the video? Inside the video there are pictures, sometimes 25 pictures per second, sometimes 50. For example, on the satellite, we are broadcasting 50 frames per second. Inside picture there are numbers, and in each picture there are 3 matrices, that one for red color, one for blue color, and one for the green color. That's for our trichromatic vision. And for a convention, there are the I number are related to light colors. If you are speaking about 8-bit, the highest number is 255. So 255 represent the white color. Low numbers represent dark colors. For example, 0 represents a black color, and in the middle there is the gray color that is represented by the symbol 127. So as I said, I won't go to all the aspects of the video compression because, as I said, it takes too much, but I want to speak just about the 3 pillars of the video compression because they are in common with AI tools. The 3 pillars are called redundancy, and there is a spatial redundancy that is a redundancy inside the same picture. That means inside the picture. The temporal redundancy, that is a redundancy between pictures, and the statistical redundancy that it's about frequencies. But the first operation of the encoder is to split the picture on the left into blocks. So the atom of the encoder is the block. And this allows the coding algorithms to, to cope with the complex and non-stationary nature of the picture. And in HEVC, advanced video coding, these blocks are called, the basic structure, is called macro block. Now with the modern terminology, they are called CTU, coding 3 unit, but I think that macro blocks can give the idea on what we are speaking about. The macro block can be further divided into smaller blocks according to the quad-tree algorithm. So the first redundancy is a spatial one, and it's about element duplicated within a structure. For example, the pixel inside an image. And for example, in this background image, there are many blue pixels, and the idea is that instead to send many blue pixels to the decoder, across the internet, the idea is to send just 1 pixel and then tell to the decoder, copy and paste it many times. And this is a big jump inside the encoder. And as you can see in the left column, there are big blocks, 32 by 32. And on the arrow tail, there is the original block, and in the arrow's head, there is the predictor. The predictor is an approximation, is a rough approximation of the original block. The idea is that we don't want to send the original block because it takes too many pixels, too many bits, sorry, but we want to be able to rebuild this original block decoder size thanks to this predictor. If the predictor is too different from the original block, as you can see in the left column, they are quite different, we need to compute the differences between these two, and these differences we call, residuals. And we should send the residuals to the decoder. And in the right column, you can see the smaller blocks. These blocks are 8 by 8, and in this case, you can see the prediction is quite good because on the arrow tail there is the original block, and in the arrow tail, under arrow head, there is the predictor, and as you can see, they are quite similar. And that means that the quad-tree algorithm works very well. The concept behind the intra-prediction is that the texture inside the block is similar to the texture in the neighborhood of that block. So it can be predicted from there. That means that the value from the neighboring samples can be combined with some math to get the predictor, to compute the predictor. And And here there are two, AI paper related to intra prediction. The first one is interesting because the authors discovered that approaches like convolutional neural network are not so useful for small blocks, because sometimes the the kernel is bigger than the blocks. So in this case, it doesn't work. So because of that, they used for the small blocks a fully connected neural network, and for the big blocks, they use the convolutional neural network. And so they have two networks, and they decide which one to use according to the size of the blocks. Another thing is interesting, and is that they train over the uncompressed input. That means the undistorted input, and then they discover that the network has good generalization capability, because they applied to the compressed to the distort signal, and they find that it works, the network. And this is a good news, because it it can simplify a lot the training phase, because you don't have to take into account the quantization noise. That is very good news. In the second paper, the approach is a bit different. The authors added other intra-prediction modes, other 45 intra-prediction modes. In the VVC, that is the current standard, there are 65 intra-prediction modes, and these authors added other 45 predictors. And by the way, this is the only AI tool inside the new standard, the VVC. And the authors started with, neural networks with many layers. Then, because of the complexity issue, they simplified, and now they have just one layer. So I wouldn't say that, it's a deep learning approach, because one layer is kind of matrix multiplication. By the way, it's the only AI-based tool that it's inside the new standard. Okay, speaking about the temporal redundancy, can you spot any differences, any difference between these four pictures? It's a bit difficult, but they are the first four frames of a video sequence. And the video sequence is sampled at 30 frames per second. And when the frequency is higher, for example, 50 frames per second, it's even more difficult to spot any difference, because the movement is kind of frozen when the sample frequency is so high, for example, 50 frames per second. In this slide, I have overlapped the first two pictures, and now you can spot the movement, of course, in the sail of the boats. And moreover, I have marked with these arrows, and that we called motion vectors. And so the idea is to, instead to send these four pictures, the idea is to send just the first picture and then tell to the decoder, if you want to rebuild the second picture, the current picture, copy and paste for the first picture that you have received. But when you see a motion vector, move the block in a position according to the direction and to the module of that motion vector. And these blocks, of course, are predictors, and as always, the better is the prediction, the lower is the energy of the residuals. And this is another big jump inside the encoder, and here I have overlapped the two blocks. I mean the original block and prediction, because the prediction is very good, is quite similar to the original block. So in order to visualize the small differences, I had to overlap these two blocks. And if you see the double edges, is because there was a panning, that means a camera movement. But still you can see that the difference between these two pictures is very small. That means the residual are very small. That means again that the prediction, the inter-prediction is very good. And again, there are two approaches related with the temporal redundancy. The first one is in the first one, the authors even don't send any motion information, because even sending the motion vectors, it takes bits. So the idea is to don't send anything. And this approach, they don't send any motion information. They use a convolutional neural networks, and they give an input to two previous frames, and they get in output a new frame that they called deep frame, and deep frame is used as a predictor for the current picture. In the second paper, the approach is quite different. They use a generative adversarial network. They give an input for the four previous frames, and they get a new frame that they call extrapolated frame. And at this time, this frame is used inside the encoder as a reference frame. That means the encoder when copy and paste information for this frame, for this new frame. And the last redundancy is the statistical one, that is about frequencies. I mean, if the encoder mapped the most frequent symbol to the shortest group of bits, it gets in output a shorter bit string. I mean, in the first row, for example, the white pixel is represented by the symbol 255, as we said before, because we are, for example, we are speaking about 8-bit. If the frequency is, if it appears 80% of the time, and if we represent with just 2 bits, and then we represent the less frequent symbol with a longer group of bits, in this case, at the end, we get a shorter bit string. That means we are saving bits. And here is the traditional video coding schema. It's quite famous. It has more than 40 years, and you know, so there is a prediction stage here where the codec tries to exploit the temporal and spatial redundancy, and the spatial redundancy, that means inside the picture, it is called intracoding, and the temporal redundancy, that means between picture, is called intercoding. And then it produced the predictions. So the prediction, as we said, is a rough approximation of the original frame. So we need to compare with the original input block in order to get the differences between these two. The differences are then that we call residuals. The residuals are then transformed by the DCT, that it is the discrete cosine transform, in order to represent the residual in a more convenient domain, more convenient from the energy point of view, of course. Then there is a quantization process that is the lossy part of the encoder, but it is also the part that saves bits. And then there is the entropy coding to exploit the statistical redundancy. And then there's the output bit streams that goes to the decoder. And this part we call, you know, in loop chain. And it's in this part we reconstruct the picture in order to store them in a reference buffer in order to exploit the temporal redundancy, because as we said, to exploit the temporal redundancy, we need 2, 3 or more previous frame, and these ones are stored inside a frame buffer. So, I try to find an evidence that of the AI added value to the video coding, because usually in the papers authors just replace one module of the traditional video schema with another AI based. But I just wanted to know an upper bound. That means how much we can gain if we replace as many modules as possible. So I try to find an hot number, and I did in this way. I read many papers, then I fill this table, and then I did something very, very bad. I added them together, and I got this this value. It's about 30%. Why it is bad? Because authors of the paper used different settings, different parameters, different train set. So, I mean, they didn't use a common test condition, so it's difficult to compare these results. Moreover, the addition is a linear operation, and but the underlying process is strongly not linear. And but just I wanted to have a rough approximation of how much we can improve adding AI tools. And I found this number 40%, that 40% is kind of magic number in video coding, because, for example, HEVC was 30% better than AVC, and now VVC is 30% better than HEVC in objective measurement. So take this number as a as a rough approximation that it says that there is space for improvement if we apply AI to video compression. Then I did the same with the end-to-end architecture. This kind of architecture is a kind of disruptive architecture. That means that everything is based on AI tools, and that means there are no legacy algorithms inside. And again, I have found almost the same number, or the same percentage. That means 40%. So there is enough space of the improvement if we apply AI to video compression. Of course, there are open issues. All the contributions, all the papers are based usually on authors' test and train sequences, so it's difficult to compare the results sometimes. Because of that, there is strong needs for common test conditions. And also there is an issue with the objective matrix. SSIM, the structural similarity index, and PSNR, the peak to noise ratio, are well used, I mean, in the scientific literatures, but they are not well correlated with the subjective evaluation. And that's a problem. So there is needs for an objective matrix that gives valuable results correlated with the subjective evaluation. The last point is it's about the performance. I mean, the performance is nothing without complexity, as we said about all the work in MPAI in the loop filter, but also it's the issue comes especially in the decoder side, because, for example, for the phone batteries, if the complexity is too high, the batteries end up very fast. And just I want now to share with you some concern. I mean, in MPEG, they are building their own dataset, but this dataset is quite different for a broadcaster dataset. I mean, there are no sports, no commercials, no content from archive, no documentaries. It's quite different. They are training their AI tool on their data set, and in a few years, usually from 7 to 9 years, they will publish the new standard. So what will happen when we will use this standard? I mean, do this standard work on broadcaster contents? For example, we decide to broadcast an old content from archive, and the algorithm removes the film grain because it thinks it's an artifact. Maybe it will happen, who knows? And the second bullet item is, maybe it's a philosophical question. The GAN, the generative adversarial network, are very good in rebuilding the content. And but do you want the truth, or do you want a better content? Because, for example, we can get subjective high quality, but we can lose the fidelity. For example, in a facade of a building, the GAN maybe replace this facade with another one with a different kind of facade, and maybe with high quality, but in this case we are losing the fidelity. So I mean, again, do we want the truth, or do we want a better content? This is a more philosophical question. And it comes with a conclusion. So why AI tools works well with video coding? But in general, because they are able to distill aspects of the semantic of the data that are relevant to video coding. In particular, they have a very good content adaptivity, because their weights and parameters are derived from lots of real data, while in the traditional video algorithm are handcraft, leveraging on prior information. That means that they are agnostic to the data. The second item is that traditional video codec use neighbor samples, as I said in intra prediction, to build their prediction, to build their prediction. But in the neural networks, large receptive fields are widely used, which means that they can use not only the neighboring samples, but also they can improve the coding efficiency by leveraging on samples from far distance. And neural networks also can well represent both texture and features, and this enable the joint compression optimization. And also the whole compression system is end-to-end optimized, while, for example, in traditional video coding schema, the optimization is just inside each module, but the modules don't speak each other. And that's all for my side. And thank you for the attention. Any questions?
Thank you, Roberto. Thank you very much for your good insight in your research. I have a question. It's like, what excites you in the moment most about? I mean, you showed a lot, but what excites you concretely about AI and media research in the moment? What is your passion?
Oh, thank you for the question. I think, I mean, as I said, it's an interesting time because there are these three international groups that are competing to win the only one standard. And in the past few years, there was just MPAI. In the past 30 years, there was just MPAI, but I think with the competition, things are getting interesting, more and more interesting.
Mm-hmm. Thank you. And you are, like me, in AI for media. What is your role there? What are you doing? What is your objectives to be in this research project?
Thank you for the question. As arrival in AI for media, we proposed a use case called AI in Vision for high quality content production and content automation, and it's a wide use case that impact a wide range of application from environment investigation, historical reporting, just-in-time content productions, and it also impacts the whole production chains, and also many actors from journalists to content producer, archivist, and these kind of things. And we think this is a very good use case, and I think this is 4-year project. I think so we can get a very good result from this AI for media project.
Yes, thank you. And now, for example, we take a TV station, we take RAI. If you really, I mean, are you using AI standards now, or will it come in the future? Is it applied now?
For the moment, as RAI, we are, in the, let me say, in the research phase, because, AI tools are very good, but, when we should apply to the industry, when we move from the academic to the academia, from the academia to the industry, from the academia to the real life, AI tool need to be, tested many times and, checked many times. Do you know what happened to that football match where the AI tool was supposed to follow the balls, and instead it was focused on the heads of the referee for all the time? These kind of things. AI tools are very good, but they need to be, checked and tested many times. We need to digest them before putting them into the production chain.
Yes, it's like, can you see a scenario like I'm a watcher, I'm a consumer? What would change for a consumer, like for like we take sport, no? I like the sport example. So as a consumer, would I then see at the same time many different perspectives, or is there anything what the consumer would feel when you use AI?
Sorry, I didn't get.
What would be the benefit for the watcher, for the TV consumer, if you like see sport? I like this example on sport. Is there something which like AI would make better?
AI could, I mean, we have a lot of user stories in AI for media about this topic. AI could improve at first the quality, the video quality, and then as you said, the perspective, because it can generate new point of view. For example, also it can merge shots from drones, from camera on the ground, and from heterogeneous sources, from reconstructed picture acquired from point cloud, and then after the 3D reconstruction. So you can merge many heterogeneous sources, and you can get very impactful new point of view that we can deliver to our customers.
Yes, yes. Thank you, thank you. So I would like to come slowly to an end. One last question. Like as we are here also AI for EU and AI for media, we are trying to get more and more young people, talents, and SMEs and startups in this media and AI for you, basically themes. How would you say we could get more startups, SMEs interested in AI and media applications? Any clue?
But I think this AI for media project is a very good opportunity also for startups, because in my understanding there is also the possibility for you know, companies from actors outside the project to collaborate in some way. But also, I mean, also we are as RAI, we have a lot of collaboration with startups, with, you know, academia, and we are trying to, you know, to build a network of collaborations between, I mean, this is the way of the research, no? I mean, to build a network and work all together to reach our goal.
Yes, thank you. This comes, I'm asking this last question because it bridges, of course, tomorrow to the cafe tomorrow, and here we are bridging over. Tomorrow is AI for you open call for challenges. It's a cafe session, a special cafe session tomorrow, and you can learn how you get 70,000 euro by being, for example, a startup or a developer, and discover AI for you challenges in health, manufacturing, and agri-food. Unfortunately, it doesn't say media. It says health, manufacturing, and agri-food. So, but that doesn't mean that you can use media for health. It's maybe also possible. Anyway, this is the cafe tomorrow, and the speaker will be Ursula Sobeck from Funding Box, and all the challenge owners will come also tomorrow to the cafe. So it would be great you're coming back tomorrow. It's at the same time. And meanwhile, I want to ask you, Roberto, is your presentation available? I mean, do you mind to send it to me and I can send it to people who would like to read it, or you don't want it?
Yes. Sure. I will send to you. Yeah, no problem.
Great. So that means whoever likes to have the presentation, please write me an email. Secondly, I will send the recording of this session to Roberto afterwards, after when we are now closing the session. And if you agree, then it will be, as always, in the AI for you video channel on YouTube very soon. Okay. So thank you very much.
Thank you.
I have one. We have still one minute. Sorry. Sorry. I want to let you go, but there is.
Okay.
Yeah. How
no problem.
You have to edit a footage coming from different sources and compressed with different codec. Will AI help for the interoperability of different codec, or for the future you envision that there will be a dominant codec leading the market? You understand?
That's a very interesting question, Carmen. Thank you. It's, I mean, I don't really know, because there are these three international groups that are very competitive, very, you know, very strong, and it's difficult to forecast who will win the race. I mean, I think it's too early to give an answer. I think we need to wait at least a few years. Not a few years, yes, at least a few years to understand which one will be the winner. For sure, MPAI, you know, it's a very successful group, so, you know, it will be the driver of the AI applied to video coding. And I think that Alliance for Open Media, it will be more related to the broadband. That means inside the browser, you know, or video on demand, this kind of thing. And MPAI is an interesting group because it's you know, it's founded on artificial intelligence. I mean, there are no legacy tools, so it will go very fast in applying to video coding. So I can't say who will win the battle. Just need to wait.
Okay, here I have now last minutes. It's always we were store, but now we coming 1 minute back because we have 5 minutes more. Victor Jerry Ferrari dos Santos, thank you very much for your presentation and your time. Why do you think that this technology is not yet out in the market? Question mark. As you stated, there seem to be many efforts in the matter. I'm surprised this has not happened already.
I think it's because the complexity. Because for the moment, the complexity is too high. You know, a video codec is a general purpose codec that should run on your TV set, set-top box, mobile phone, and so you know there are strong requirements. For example, for I mean, TV set are not they usually don't have a they have limited computation capabilities. The complexity is still an issue. But I think there are, good news from the hardware point of view. For example, there is a chip M1 from Apple that, it's on iPhone. So the news that they are ARM. So I think in the next few years we will see kind of a hybrid between CPU and GPU, or kind of something like that. So I think there are also good news from hardware. So I think it's just a matter of time. And I mean, the thing that has slowed down the application of artificial intelligence on video coding is just because of the complexity. It is too high for the moment.
Yes. So now, but the last, then goodbye. Olga Casado Rodriguez. Good afternoon. My name is Olga Casado. Thank you for all the information given at the webinar. I want to know Roberto's opinion about the skills which are needed to use technology based in artificial intelligence in journalism, such as video compression. Do you think that journalists need to learn about technology and artificial intelligence, or that engineers need to know about communication? That's the question.
Oh, thank you. That's a very interesting question. Yeah, yes, I think, it's difficult to answer to these questions, but I think that it's already happening. I mean, journalists don't work, alone like before, but they have a group, and in the group there is the data engineer, there's a journalist, there are many, and it's because, it's unlikely that the journalists will learn how to deal with AI tools. No, it's another career, another background. So probably the good thing to have a group with different, different backgrounds, from engineering background, journalist background, and so on. But there's also a possibility that this AI tool will be will become easier and easier and easier, because it's already happened. I mean, a few years ago, it was so difficult to use these AI tools. For example, to use the framework, TensorFlow, Python, things. Now it's quite easier because things are improving, and when things improves, they get easier for to be used from large audience. In internet, there are many AI tools used from everyone, and because I think you have seen a lot of video published on Facebook, YouTube, and so on. So from guys that are using that learns how to use AI tools and then apply to different aspects of their life. So things are getting easier, and so it's just a matter of time, I think.
Yes. Okay. Now, thank you very much.
Thank you.
The door, and then 3 people. Hey, I have a question. Thank you. Great. Thank you for your question. Thank you for your answers. Thank you. So have a nice afternoon, and I'll see you soon again, and thank you, Roberto, no? And bye-bye, no?
This opportunity, and thank you also for the question. They were very interesting. Thank you.
Bye.
Bye-bye. Thank you.
Bye.